Welcome to The Explainer. Today, we're exploring something that completely flips how we look at our own safety. Usually, when we think about cyber threats, we picture stolen credit cards, maybe leaked emails, or a hacked social media account. Annoying? Absolutely. But they're contained entirely within our screens. Today, though, we're looking at a pretty chilling new reality. We're going to examine how a piece of digital code, something totally invisible that you can't even touch, can literally reach out of a computer network and physically break the tangible world around us. We're taking a deep, detailed look at the anatomy of a threat that permanently changed the landscape of modern security. It crossed the boundary from a digital nuisance straight into physical destruction. So, how does a simple line of code turn off the lights for an entire city? To answer that, we have to travel back to December 2016 to a massive transmission substation in Kyiv, Ukraine. Imagine this. It's the middle of winter. Temperatures are absolutely freezing. And suddenly, with zero warning, the power just drops for hundreds of thousands of people. Lights go dark, heaters shut off, and homes are just plunged into the cold. But here's the crazy part. There was no physical explosion at the plant, no massive winter storm ripping down the poles, no broken wires. That entire blackout was triggered by silent, invisible lines of code. Section 1. The ultimate grid killer. Okay, let's dive into this. The culprit behind that devastating blackout in Kyiv is a piece of malware known as Industroyer, or as some security researchers call it, CrashOverride. Today, it's widely considered to be one of the most dangerous pieces of malware ever discovered. But to really grasp why it's so uniquely terrifying, we need to understand how it operates on a basic level. Let's compare Industroyer to a previous attack that happened exactly 1 year earlier. That one involved malware called BlackEnergy. Think of BlackEnergy kind of like a digital burglar. The burglar uses their tools to quietly pick the lock, break into your house, and open the front door. But once that door's open, right, a human hacker still has to physically sit at their keyboard halfway across the world, stare at a screen, and manually click the digital switches to turn off your power. And a human hacker is a massive bottleneck. They need sleep, they make typos, they have to figure out what they're even looking at. All of that takes time. Industroyer, it's a massive, unprecedented leap forward. It's a fully automated robot. The attackers literally just drop Industroyer into the network, and they can walk away. The malware doesn't need a human behind a screen. It's totally self-sufficient, pre-programmed to automatically execute its strike, dismantling the power grid all on its own in a matter of milliseconds.
Section 2. Speaking the machine's language.
Now, for a piece of code to automatically flip switches in the real world without a human clicking a mouse, it actually needs to know how to give commands directly to massive industrial equipment. And to give those commands, it has to speak the exact right language. Which brings us to a term you hear a lot in cybersecurity: protocol. In really simple words, a protocol is just the native language that machines use to talk to each other. When your web browser wants to load a picture of a cat, it uses a specific internet protocol to ask a server for that image. But an industrial protocol is a whole different beast. When a computer needs to tell a giant steel, high-voltage circuit breaker to physically snap shut and cut power to a city, it doesn't use English, it doesn't use Spanish, and it definitely doesn't use web browser language. It uses a highly specific industrial protocol. This right here is exactly how the digital world reaches out and shakes hands with the physical world. What made this malware so devastating was its unprecedented level of fluency. Industroyer wasn't just built to speak one narrow language. No, it was engineered to speak 4 distinct global standards for power system automation: IEC 101, IEC 104, IEC 61850, and OPCDA. Usually, malware has to be custom built for one specific brand of equipment. It's like a key that only fits a Siemens lock but is totally useless on an ABB lock. But by mastering these 4 specific global languages, Industroyer became a master skeleton key. It could walk into almost any power substation in the world and just start shouting orders. It didn't matter if the physical hardware was made by Siemens, ABB, or General Electric, Industroyer could seamlessly speak to all of them. Section 3. A digital Swiss Army knife. And this brilliantly illustrates how it actually works. Because it could do so many things and speak so many languages, Industroyer basically functioned as a digital Swiss Army knife. It was built with this highly specialized modular architecture, meaning it's made up of different interchangeable tools built for very specific jobs. Let's break down the 4 main tools in this kit. First up, you have the main backdoor. This is the quiet entry point that secretly connects back to the attackers and unpacks all the other tools. Second, the payloads. These are the actual weapons. They're specifically loaded with those industrial protocols we just talked about, so they can directly target the grid. Third, the port scanner. Think of a network port like a door in a massive office building. The scanner acts like a scout, quietly walking down the digital hallway, jiggling door handles to find out which ones are open, mapping the internal network to locate the specialized industrial controllers it wants to hit. And finally, the wiper. I want you to think of the wiper as the getaway driver who tosses a match and completely burns the getaway car after a bank robbery. Its sole job is to destroy the infected computer system files and registry keys. Simply put, those are the computer's fundamental memory and brain. By wiping them out, the whole computer becomes totally unbootable. It literally leaves a pile of useless digital ash so that no one can easily trace the attacker's tracks. Section 4. The infinite loop effect. All this modular programming translates into pure, terrifying chaos for the engineers on the ground who are just trying to keep the lights on. Picture an engineer at that Kyiv substation during the attack. Alarms are blaring, red lights are flashing everywhere. Step 1, the malware sends an automated command to open the circuit breaker, cutting the power to the city. Step 2, the human engineer, seeing the power is out, rushes over to the control panel to manually close the breaker and restore electricity to all those freezing homes. But then comes step 3. Like a digital ghost, the malware instantly detects this human action and immediately forces the breaker open again. It traps this massive physical machinery in an infinite loop of opening and closing. This creates what's called a dangerous cycling effect. And we aren't just talking about the lights flickering here. Giant metal machines are absolutely not meant to snap open and shut rapidly. This intense, rapid cycling causes massive friction, intense electrical arcing, and an extreme buildup of heat. This infinite loop can literally melt or blow up the physical hardware in the substation. It makes manual recovery nearly impossible and incredibly dangerous for the operators standing right there on the ground. So when we compare the older BlackEnergy-3 attack to Industroyer, the sheer escalation of the threat becomes terrifyingly clear. We moved away from manual sabotage, where a human actually had to click a mouse, straight into completely automated grid disruption. The destructive tools shifted from just wiping computer hard drives to creating those physical, hardware-destroying protocol loops. And most crucially, the attackers stopped aiming at standard IT computer screens. They started aiming directly at the power grid protection relays. Put simply, protection relays are the vital safety fuses designed to detect electrical anomalies and shut the system down to prevent explosions. The attackers literally took the very safety mechanisms designed to protect the grid and turned them into the weapons that destroyed it. Section 5. The Industroyer 2 Evolution. Unfortunately, a weapon this effective rarely just stays dormant. During the conflict in Ukraine in April 2022, cybersecurity defenders made a pretty grim discovery. A new variant had entered the battlefield. Tracking this timeline historically gives us a really clear picture of how this threat escalated. December 2015 brings the first BlackEnergy attack. Exactly 1 year later, December 2016, we see the Kyiv Industroyer attack, which introduced massive automation. And then, there's a gap of several years, until April 2022 when Industroyer 2 is discovered. This gap is so vital to understand. The attackers didn't just walk away and celebrate their success in 2016. No, they spent years back in the lab, quietly refining their digital weaponry to make it faster, more efficient, and much, much harder to detect. So how exactly did it evolve? Well, first, it completely ditched the Swiss Army knife modular approach. Instead of unpacking a bunch of different tools, it became a single, standalone executable. A lean, mean, all-in-one piece of software that was incredibly fast. Second, and this is critical, it had hard-coded target configurations. To explain this simply, instead of dropping a soldier into a maze and telling them to look around and find the target, the attackers gave the malware a hyper-detailed map with the exact GPS coordinates of the target already memorized. They had done intense reconnaissance beforehand, figuring out the exact internal addresses of the hardware at one specific substation, and literally baked those details directly into the malware's brain. It didn't need to think, it didn't need to scan, it just needed to strike. Finally, they stripped away all those multiple languages and streamlined it primarily for just one protocol, IEC 104. They sacrificed the ability to attack anywhere in exchange for the ability to attack one specific pre-chosen target with blinding speed and devastating efficiency. As we look at this progression, from manual hacking to automated disruption to highly customized, lightning-fast digital weaponry, I want to leave you with this question. If a simple line of digital code can physically break our grid in seconds, what happens when it evolves to target everything at once? Industroyer proved that our physical, tangible world, the literal warmth of our homes and the lights in our cities, is deeply vulnerable to invisible digital languages. Defending our critical infrastructure going forward doesn't just mean building thicker walls or stronger locks. It starts with understanding these invisible forces. Thanks for joining me in this explainer, and keep asking the big questions.